Okay, guys, welcome back. We're going to go over the single phase equipment, what powers up our model. So we told you about the generator. It's a 120, 240 generator. So we need 240 to power up this phase converter. So this phase converter, it comes in 240 volts, single phase, and then it comes out 240 volts delta. From this point, once it leaves the phase converter, it comes into the transformer over here. This is our three-phase transformer. It comes in 240 delta and comes out 120 208 Y system. That is what our model is based on, is a 120 208 primary Y system. From this point, it leaves the three-phase transformer, comes into the fault current reactor. This is what protects the equipment. It protects the model, it protects everything. So basically all this is A, B, and C phase. These are three rheostats that are in series with each phase. So we could choke off the fault current using the rheostats. And they are adjustable. So let's just say the voltage drops a little bit on the model, but we know it's protected and everything is good. We can actually take some resistance out of this and actually bump the voltage up a little bit by taking resistance out of the circuit. And again, once it comes in, this is protecting it. We're always monitoring it with the voltage and current meter. The voltage meters are set up with, they're set up in series with the actual rheostat themselves, not the incoming voltage, but how the rheostat is set up. So when there is a fault, the voltage will drop and the current will shoot up. And the max that the current will actually get as far as a fault per phase, we've seen it go up to about 2.5, maybe 3 at the most. So the fault current is very minimal, even with what we're dealing with. But again, we can discuss that later on. But right now, just how the equipment works, once it leaves here, it goes to the model itself. So the cable is actually ran underneath, it's tucked underneath the model real well. Comes in right here, powers up the model. And explain this briefly, this is a three-phase breaker box. This is for the instructor. He's the one that's monitoring. The green lights on this mean that there's power. Just like all this equipment back here I showed you, we'll talk about it in a minute. The green lights indicates that the equipment has the power. The red lights indicates that the breakers are either closed or they're open and being backfed. So we have indicators on all this equipment at all times, so we know the status of the equipment. But with that being said, we're going to take a break, and then I'm going to show you how we power this equipment up.